Okay, today we're going to talk about the area and circumference of circles and composite shapes. You can see the formulas for circumference, pi times diameter, or circumference equals 2 pi radius. Of course, D stands for diameter, R stands for radius. I'm hoping everyone's got that. Area equals pi r squared. One time I heard someone, they said, the way they remembered the formulas, they said cherry pie is delicious, apple pies are too. But you've got your formula charts, you've got those. All right, find the circumference and the area. Leave your answer in terms of pi. So this is back to where we want you to find the exact answer and don't put 3.14 in your calculator. If ever you are rounding off though, don't put 3.14. Use the pi button. That's going to get you a more accurate representation of pi. It's second and then the caret. And it'll give you more decimal places than 3.14. So if ever you do actually round off to the nearest thousandth, which by the way, we always round off to the nearest thousandth if we're rounding off. I had some people round to whole numbers. It was weird. Okay, so for this one, circumference, 5 represents which part of the circle? The radius. So I'm going to use the 2 pi r formula. Circumference equals 2 pi r. So plug my 5 in for r. 2 pi times 5. And to leave my answer in terms of pi, I'm going to write 10 pi. You multiply everything except the pi, and then you just stick the pi at the end. And if you did want to round it on your calculator is super smart. You could put 10 pi. You don't even have to put a multiplication in there. Just write 10 pi, and your calculator will do it. It knows you want to multiply. So just, there's that. But for leaving it in terms of pi, the exact answer is 10 pi centimeters. I won't be counting off for units. All right, next up, we're going to find the area of the circle. Area is pi r squared. Don't forget the squared. And don't square the pi. Just square the r. So the radius was 5. So I'm going to say pi times 5 squared. And please multiply that out and tell me that the area is 25 pi square centimeters. Again, I'm not marking off for units, but I'm just including them because it's actually correct. Yes, ma'am.
So we don't need a decimal, like the actual answer?
Nope. Leave your answers in terms of pi. This is the exact answer. I prefer it. It's easier. It's even less work. Any questions so far? Yes, sir.
So you would never convert pi to
Sometimes you might, but most of the if it says leave your answers in terms of pi, or if it says give the exact answer, this is it. It's much easier. All right, ready for the next? Find the circumference and the area. What did they give us this time? Diameter. So circumference equals pi times diameter. So all I have to write is 12 pi. Oh, 12 pi, that's it. No, you don't even have to calculate anything. Now for area, remember area is pi r squared. So what's the radius? 6. So remember area requires radius. So we had to take half of the 12. So my answer would be 36 pi. That's pretty easy. So far, so good. Alrighty. Next. This one's interesting. We've got a bicycle tire, and it says to the nearest foot. So we are going to round off on this one. How far does the tire travel when it makes 15 revolutions? So we've got the tire, and let's just pick a random spot on the tire. When the tire makes 15 revolutions, how far has this point traveled? Is basically what it wants to know. So when we're talking about the revolutions and how far it travels, which are we talking about, the circumference or the area? Circumference. So let's find the circumference of the tire. That would be 1 revolution. and then do what? Multiply it by 15. So what is the circumference? That was pi d, correct? So 15 pi. And then it's going to make 15 revolutions. So 15 revolutions times 15 pi. I'm going to go ahead and put that in my calculator because it said round off to the nearest foot. So they don't want the pi in the answer because it says round to the nearest foot. So here goes. 15 times 15 pi. Please remember to use the pi button. We're not in middle school. Sometimes they said use 3.14. In elementary school, sometimes they said use 3. I like when my kids brought that home from school. I was just dying. Okay, so 15 times 15 pi, 706.8. So to the nearest foot, 707 feet. I'll put a little approximately there since we're rounding off. Does that make sense? Okay, good. Now we're going to do the same question kind of in reverse. A car tire has a diameter of 28 inches. So you're going to learn really quickly that I can't draw circles, so just bear with me. So the diameter is 20. Yeah, I draw eggs. It just happens. The diameter is 28 inches. How many revolutions does the tire make while traveling 500 feet? So they're kind of going backwards, aren't they? So it's this question only in reverse. So let's find the circumference of this tire, which is 28 pi. And we want to know how many revolutions it takes to go 500 feet. Who's got a thought on that one? Yes. Divide it by 500? Or do 500 divided by 28 pi? Okay. Be careful putting this in your calculator because if you do it this way, 500 divided by 28 pi, your calculator is going to divide by 28 and then multiply by pi. That's not what we want. If you do it this way, you would have to put parentheses there. So the calculator would know multiply 28 times pi and then divide. Or if you prefer, alpha y equals gets you that beautiful fraction, and you can just type it in like this. So just be careful how the calculator does what you tell it. So you have to tell it the right thing. So what do you get? 5.684 revolutions? Because it didn't tell us where to round off, so I'm going to go ahead and say 5.684 revolutions. That's an interesting question. So once you did number 3, hopefully number 4 was pretty easy because you were like, hey, that's the same thing. Are we still good? Okie dokie. Number 5. We have a track. The curves at the end of the track are semicircles. So everyone knows what a semicircle is, right? Half a circle. If a runner is in the first lane, which is this one right here, if you can't see, there's the radius. How far does she travel around the track? So we've got our semicircle, and then we've got our straightaways, and another semicircle, and another straightaway. So this is our introduction to the composite shapes. What happens when I take the two ends of the track and put them together? It just makes one circle. So I basically need the circumference of one circle plus the two straight lines. I'm not writing chemistry, I promise. Kind of looks like a chemistry equation. Circumference of the circles, which is, we put the two half circles together and get one, and then the two straightaways. Now, looking at the question here, it says round to the nearest thousandth. I was going to say, looking at the question, I see decimals, so I'm thinking my answer is probably in a decimal. So that's kind of a key you can use there. Well, let's try it. What's the how do I find, Helen, how do I find the circumference of my circle? The circle parts.
2 pi radius.
Okay, and the radius was 36.8. And my straightaways were 84.39, and there's one on each side. And then I'll just plug that into my calculator. Be sure you're always showing your little pieces that you plug into your calculator, because if you just plug it into your calculator without any work and it's not right, I can't give you credit for anything because I don't know what you put in. So grab the handy dandy calculator. We're just going to type in 2 pi times 36.8 plus 2 times 84.39. Anybody get 400? Does that surprise you? That one time around the track is 400 meters?
Oh, no. Wait.
Isn't that what we expected it to be one time around the track?
Yeah.
400 meters? Aha. Now, I didn't tell you how far it was to the outside lane. Does it make sense that if you ran the outside lane, you'd run a little bit further? That's why you always see runners shooting for the inside lane, because that's the shortest way around the track. All right. Questions? That makes sense now. Are we okay? All right. Back page. We've got a lot of composite shapes. So let's take a look at these. I had fun drawing these pictures. Find the area of the shaded region. Leave your answer exact in terms of pi. Some of these answers are going to look really weird, like it's going to be 86 minus 25 pi. And you're like, can I really leave it like that? Yes. So some of these answers are going to look really funky. So let's take a look at our square with a circle inscribed. Any ideas, Alprin, on any strategy on this one?
Find the area of the square and then find the area of the circle. Subtract the area of the circle.
Okay, so square minus circle. Is that a good strategy?
Yeah.
All right. So area of the square. Lucas, what's the area of my square going to be? Okay, 400 is the square, because we know a square is 20 times 20. Now, the circle. Anya? I'm sorry. Okay.
So it would be pi r squared.
Okay.
The radius is 10, so it would be pi times 10 squared.
Good call. So remember, your diameter is 20. Remember to find the radius before you do pi r squared. So that is 100 pi. And guess what? That's it. The directions said leave it. So leave it in terms of pi. Any questions? All right. Number 7. Okay, it's kind of the same thing. This time we have a rectangle with some circles inside of it. So Janet, what would your strategy be on this one? Okay, 6 circles. And then what are we going to do with that? There you go. The rectangle minus 6 circles. So I always like to start out my composite shapes like this. I kind of get a strategy. Okay, I'm going to do rectangle minus the circles, and then I can fill it in. Well, what are the dimensions of the rectangle? Did they give us enough information?
Yes.
Shrey, you're saying no. Or are you saying no? Did they give us enough information to find the dimensions of this rectangle? The dimensions of the rectangle. Can you figure it out?
Yes.
What is it?
Can't you just do the 2 diameters?
Great thought. He said, can't we just do the 2 diameters? I gave you the radius of the circle, and this is going to sound funny, but the radius of the circle is the same no matter which way you draw it. So I drew it here, but if I draw the radius here, isn't it still 7?
Yeah.
So the diameter is 14, and there's 2 of those,
28.
so that's 28. Now I go this way. Okay. So the area of my rectangle is 28 times 42. And my circles, the radius of one circle is 7. So 6 of those would be 6 times 49 pi. So you just tackle it one little piece at a time. Grab the calculator. 28 times 42. 1,176. And then 6 times 49 pi. 294 pi. Please do not subtract those because this one's got a pi and this one doesn't. This is it. That is the answer. If the directions asked you to round to the nearest thousandth, you would actually multiply by pi and subtract them. But it says leave in terms of pi, so you are done. Don't do anything else. I like in terms of pi because it's easier to grade. It's just easier to do because it's less work, less numbers you have to type. So you multiply your numbers without the pi, and then you just stick the pi on at the end. Please don't subtract those again. They're not like terms. Are we still good?
Yep.
Okay. See, circles aren't so bad. Oh, what do you think of number 7? Let's see. Akash, what do you think we did here? Uh-huh.
Well, you know the diameter of the circle is 14.
Okay.
You do 18 times 14 to find the area of that thing. And since they're both semicircles, you can do you can do 49 times 5. And then that'll get you the area of 2 circles, and then you could do 18 times 14 minus 49.
Okay. You are correct. Did you notice this was a rectangle with a circle chopped out? It's actually 2 semicircles. So, which 2 semicircles add up to 1 circle. So we're saying find the rectangle and subtract the circle. Just like with the square question. Okay, and here's what he said if you missed it. 7 was the radius, so this entire length was 14. So base times height, minus and my circles has a radius of 7, so he said minus 49 pi. Now I just have to multiply. Are we still making sense? I hope.
Yeah.
252. So 252 minus 49 pi. I like this circle stuff. All right. Next. Well, anyone want to lay out a strategy for this one? Helen?
Do the what's it called area formula for the triangle, or have the base times height, and
Okay.
And 5 is the height, and then you just do 5 plus 5 is 10, because that's the way it's across.
And then what?
5's the height. Because it's like,
What do I do with the circle?
the circle you find the area of it.
Okay. And then what am I going to do once I find the area?
Both of them.
Okay, that's where I was headed. So I wanted to, like, you guys your brains are so far ahead. I just wanted to do the basic circle minus triangle. So we know where we're headed. Circles pi r squared, and Helen said, well, the radius is 5. You gave us that. So 25 pi. Now the triangle, we have to do base times height. How do I know the base of the triangle?
Because the diameter of the circle
Yeah.
is 5 times 2, which is 10.
Remember we said the radius of the circle is the same everywhere inside the circle? So if this radius is 5, guess what this radius is?
5.
And this radius?
5.
So my base is 10, my height is 5. So 1/2, 10 times 5. So 25 pi minus 25. Very good.
It's actually not bad.
So just look at your picture, figure out, do the whole thing minus the part that got cut out. And that's what you do. All right. The last one. I couldn't for the life of me get these lined up exactly. It looks a little wonky to me. But can you tell that this ring is shaded and then this one in here is shaded? I'm going to give you guys a minute. Leave your answer in terms of pi. Literally a minute. I'm going to time you.
The outer ring and the smallest ring in the middle.
Yeah.
9 pi, and then
I know now.
4 pi. So subtract that from the.
You didn't turn on for trouble.
Okay, think of it.
Yeah,
that's how it is.
You're just trying to find the outline.
Oh, I should have found that one.
59 pi.
Oh.
Well, it's 64 times 9 pi.
Why 2 after 4?
Because
Well, he probably like.
No, he probably got the, no, he got the answer right. He just enjoyed it.
That's all.
On one question, I put a definite
Well,
that's in terms of like.
What do you do? Something like.
Not it.
I think that's what it's.
Yeah, Route 9.
Oh,
I was about to do that and double check that. 17.
Obviously, it's Route
12 times 12.
All right. It's been 2 minutes. I let you guys go. Sophia, what did you get? Yes. She got 59 pi. Did anybody else get 59 pi? That's the right answer. All right. So let's figure this out. I know for sure I've got to find the big circle, right? Big circle, radius is 8, so that's 64 pi. We're good. Now, if I've got the big circle and I subtract the next circle, this is the area that I have. So minus the next circle, which is 9 pi. But I also have this part shaded in the middle. So Sophia, what did you do to get that part back?
So I just subtracted 64 pi and 9 pi, and then I added 4 pi to that answer.
By adding 4 pi, we go back and we put the the shaded circle in the middle. So yeah, 64 pi, big circle minus the next one plus the next one. So that one was interesting. So that's our circles. Any other questions for me? All right, good job.